So we are on our last day of graphing quadratics, and we've talked about a lot of things, and today is going to be probably one of the easier days. So first of all, we need to recall that the standard form of a quadratic is y equals ax squared plus bx plus c. And this formula we've been using now for a couple weeks. Today we're going to learn about a new form, which is called factored form. Before we do that, let's look at our graph and let's just address what all of these pieces are. So I have, first of all, this dashed line that goes through the middle of my graph here. And this line is going to be my axis of symmetry, or my AOS, however you would like to write that. So it's my axis of symmetry, which comes from or is written as in equation form, x equals some number. Down here at the bottom, this point that we have down here is my vertex. And then over here on the y-axis, I have my y-intercept. Remember that my y-intercept is always in the form of 0 and then some number, and specifically, that number is always c when it is written in standard form. So my y-intercept is the ordered pair 0c. And then lastly, this is the first time we've looked at this on our graph in a while, but this line, these other 2 points that are on the x-axis here and here, these 2 points are a couple different things. So remember, they are my x-intercepts. They are also my zeros. So these 2 points on the x-axis are my x-intercepts and my zeros. And today those are going to come back into play. So next thing, we need to review this chart, or this little table that we have. So if a is greater than 0, that means that my graph is going to open up. So that's going to look like this. And when it opens up, it has a minimum value. Also, when it opens up, it has a range. That is y's that are greater than or equal to something. And then if a is negative, my graph is going to open down. And it has a maximum. And its range is going to be y's that are less than or equal to some number. So its range is y's that are less than or equal to something. The easiest way to remember that if it opens down, it has a maximum, is to think of the word maximum with a parabola in the middle for my a. So if it opens down, it has a maximum at the top. So now we're going to address what exactly is factored form, because that's, like we said, that's something new. So factored form of a quadratic is going to be in the form y equals x minus p times x minus q. And the great thing about factored form, what it gives us that we haven't been able to find before, is factored form is going to give us our x-intercepts. So when it is in factored form, I actually can find my x-intercepts easily. Which means if I can find my x-intercepts, I can also find my zeros, because my x-intercepts and my zeros are the same thing. So which of these can we find when an equation is in factored form? Well, the great thing is when it's in factored form, I can find everything. Factored form gives me, first and foremost, my x-intercepts and my zeros, so it makes those easy to find. And in factored form, it's easy for me to multiply that out to get the y-intercept. And if I have it in, if I multiply it out, I can also then find my vertex, which gives me my axis of symmetry, my range, and my max or min. And lastly, I always know my domain, because my domain is the same thing every time. So if my graph or if my equation is in factored form, I can find everything that I need to know. So let's start with, how do we find the x-intercepts? Well, remember, factored form is going to be in the form y equals, write that in black, y equals x minus p times x minus q. Now this seems rather odd, but what this gives me is that when it looks like this, x minus p and x minus q, my x-intercepts come from the p value and the q value. So how do we find the x-intercepts? It's going to come from p and q. But it's important for you to note that these are going to switch signs. That my p and my q are going to switch signs. And the reason we know that is because in the formula it says minus p, but my x-intercept is simply p, so that means they are opposites. So let's look at problems 1 and 2 from your notes. Well, if I want to find my x-intercepts, they're going to come from the numbers in my parentheses. So looking at problem 1, the numbers in my parentheses are positive 3 and negative 1. So this means that my x-intercepts are, I'm going to write them in ordered pair form. Remember, in ordered pair form, an x-intercept is always a number and then 0. So my x-intercepts are going to be negative 3, 0, and positive 1, 0. Because don't forget that they need to switch signs. This is a positive 3, so when I take it out, it's going to become negative 3. And this intercept is negative 1, so when I take it out, it's going to become positive 1. So moving on to problem 2, I have y equals x minus 6 times x minus 4. So the numbers in my parentheses are minus 6 and minus 4. So that's where my intercepts come from. So they're going to be 6, 0 and 4, 0. So looking back at the front, the next thing we need to find is we need to find the zeros of the function. Well, recall that zeros and x-intercepts are actually the exact same thing. So if I have my zeros, if I have my x-intercepts, I have my zeros because they are the same thing. So my zeros are my x-intercepts. So looking at the back on going back up to problem 1, I have x-intercepts of negative 3, 0 and 1, 0. Now, when I write my zeros, I do write them a little bit differently. I actually only write the x value of the x-intercept. So my zeros are technically just negative 3 and 1. And then looking at problem 2, if I'm writing my x-intercepts, again, it's just the x values of the x-intercept. So it would be 6 and 4. Problem 3, I have x-intercepts of negative 4 and negative 2. So that means my zeros are negative 4 and negative 2. And lastly, problem 4, my x-intercepts, my x values there are 0 and 5. So my x-intercepts would be, or my zeros would be 0 and 5. So looking back at the front, the next thing on my list is how do we find standard form? Well, in order to find standard form, I'm going to have to do some multiplication. I'm going to have to multiply out my problem that I have, either using the box method or double distributing, so that I can actually find standard form. So going back up to problem 1, I have y equals x plus 3 times x minus 1. So in order to actually find standard form, I need to distribute. I need to multiply x times x, which is x squared. And I need to multiply x times negative 1, which would be negative 1x. And then I also need to multiply 3 times x, which is 3x, and 3 times negative 1, which is negative 3. And I'm looking for my like terms. Well, I have a negative 1x that I can combine with a positive 3x. Together, that's going to give me a positive 2x. So I have the equation x squared plus 2x minus 3, and this would be my standard form. So y equals x squared plus 2x minus 3 would be standard form. So looking at problem 2, I have y equals x minus 6 times x minus 4. So again, I need to distribute. So x times x is x squared. X times negative 4 is negative 4x. And then negative 6 times x is negative 6x. And negative 6 times negative 4 is positive 24. I have some like terms. I have negative 4x and negative 6x that I can combine together to give me negative 10x. I'm going to bring down that x squared and bring down that plus 24. So standard form of this equation would be y equals x squared minus 10x plus 24. For problem 3, I'm going to do the exact same thing. So first I need to distribute. X times x would be x squared. And then x times 2 would be 2x. And then I now need to distribute 4. Well, 4 times x is 4x. And 4 times 2 is 8. I'm looking for like terms, which would be my 2x and my 4x. And 2x plus 4x is 6x, and that is a positive 6x. So I have x squared plus 6x plus 8, and that would be my standard form. So y equals x squared plus 6x plus 8. And lastly, problem 4, I have y equals x times x minus 5, so I need to distribute. Well, I just have the x in front of the parentheses. X times x is x squared. X times negative 5 is negative 5x. I cannot distribute anything else, nor can I combine anything here. So I already have my standard form. Standard form would be y equals x squared minus 5x. So flipping back over to the front, we need to now know how to find the y-intercept. Well, remember, if my equation is in standard form, y equals ax squared plus bx plus c, my y-intercept is c. So once it's in standard form, I actually already have my y-intercept because the y-intercept is c from the standard form equation. So for problem 1 on the back, I have standard form of y equals x squared plus 2x minus 3. That means my y-intercept is negative 3. Remember that all y-intercepts in ordered pair are always 0 and then some number. So it's going to be 0 and then negative 3 for number 1. I'm going to look at problem 2 where I have y equals, my standard form is y equals x squared minus 10x plus 24. So my y-intercept would be my 24 here. So in ordered pair form, that would be 0, 24. Problem 3, I have standard form of y equals x squared plus 6x plus 8. So my y-intercept would be 8. So it would be the ordered pair 0, 8. And lastly, for problem 4, I have standard form of y equals x squared minus 5x. And notice I have nothing here. And that part that should be out there, that is my y-intercept. So the question is, what really is added there? Well, the only thing that I can add that's not actually going to change the value of my problem is 0. So my y-intercept for number 4, y equals x squared minus 5x, is the ordered pair 0, 0. So that means it crosses the y-axis at the origin. So flipping back to the front, our next question, we're actually going to skip for now how to find the vertex. We're going to move on to how to find the axis of symmetry, which we actually did a couple days ago. To find the axis of symmetry, I used the equation x equals negative b over 2a. And I hope that you recall that when I use the phrase negative b, what this really means is the opposite of b. So it's the opposite of b divided by 2a. So if b was -5, and here I would put +5. And a and b, by the way, it's important to note that a and b are going to come from my coefficient of x squared and my coefficient of x. So looking at problem 1, I need to go to standard form. In order to find the axis of symmetry, I have to use standard form. So my formula for the axis of symmetry is going to be x equals -b over 2a. Well, b is the number in front of x, which in this case is 2. So when I put it in the formula, it's going to be -2, because it's the opposite of b. So -2 divided by 2 times a. And a is the number that's in front of x squared. Well, there is no number technically in front of x squared, so that number is a 1. So my number on top that I have, my -2, came from the number in front of x, and my 1 that's on bottom came from what was in front of x squared. So now I just need to do a little bit of math. Well, the denominator, 2 times 1, gives me 2, so I really have -2 divided by 2, and -2 divided by 2 is -1. So my axis of symmetry is x equals -1. So moving on to problem 2, I again need to find my axis of symmetry, which my formula is still x equals -b over 2a. So remember that b is my number in front of x. Well, my number in front of x is -10, so when I put it in the formula, it will be +10, because it always switches signs, divided by 2 times a. A is the number in front of x squared. Well, there is no number in front of x squared, so again, that's a 1. So I'm going to put a 1 in this parentheses on bottom. So just to refresh, this 10 on top came because that was the number in front of x. And the 1 on bottom I got from the number in front of x squared. So on top I still have 10. My denominator, which is 2 times 1, is really 2. And 10 divided by 2 is 5. So my axis of symmetry is x equals 5. So for problem 3, my standard form is y equals x squared plus 6x. So for my axis of symmetry, I'm going to use the formula x equals -b over 2a, once again. So b is going to be the number in front of x, which is +6. So when I put it in the formula, it will be a -6, because that's the opposite of +6. And then my number in front of x squared in this case is a 1. So it'll be over 2 times, and instead of a, I'm going to put 1, because 1 is the number in front of x squared. So on bottom, my 2 times 1 is going to give me -6 over 2, and -6 divided by 2 is a -3. So my axis of symmetry is x equals -3. And lastly, for problem 4, again, I need to find my axis of symmetry, which my equation is x equals -b over 2a, or the opposite of b over 2a. Well, b is -5, so the opposite of b is going to be +5 over 2 times. Instead of a, I'm going to put the number in front of x squared, which in this case is a 1. So 2 times 1 in the denominator is going to give me 5 over 2. And I cannot actually divide 5 by 2 and get a whole number, so I'm going to leave it as x equals 5 over 2. So now that I have my axis of symmetry, let's talk about how to find our vertex. And again, we've actually already done this. We did this earlier when we were talking about quadratics in standard form. So to find my vertex is a point. Well, the first half of my vertex is always the same thing as my axis of symmetry. So whatever my axis of symmetry is, it's going to go here for x. And then to find the other half of my vertex, I'm going to plug in the axis of symmetry into my equation and see what I get out. So for problem 1, to find my vertex, well, I already know half of it, and that half that I do know currently is that x is going to be -1. So I really know half of my vertex. So to find the other half of my vertex, and we have done this before, I actually need to take my equation. And it doesn't matter which equation you take. If you take your factored form, or if you take your standard form, I'm going to use my standard form, which says that x squared plus 2x minus 3. And instead of x, I'm going to replace that x with a -1. And I would encourage you just to put all of this in the calculator at one time and see what it gives you. And you should get an output of -4. So that is the other half of my vertex. That would be -4. So moving on to problem 2. Again, I'm going to take my my standard form, which says x squared minus 10x plus 24, but instead of x, I'm going to plug in 5 because that was my axis of symmetry. And again, I would type all of that in the calculator. So 5 squared minus 10 times 5 plus 24 is actually going to give you -1. So my vertex for this problem would be the ordered pair 5, -1. And for problem 3, my standard form was x squared plus 6x plus 8. But instead of x, we are going to plug in -3 because that was my axis of symmetry. And if you type all of that in the calculator, you are going to get -1 as your answer. So my vertex would be the ordered pair -3, -1. And lastly, for problem 4, I have my standard form was x squared minus 5x. I'm not going to worry about putting this plus 0 here because 0 doesn't change anything when I add it to my problem. And instead of x, I'm going to put 5 over 2 in here. And if I type all of this in the calculator, my 5 over 2 squared minus 5 over 2, or 5 times 5 over 2, it is going to give me as my answer -25 over 4. So my vertex in this case would be the ordered pair 5 over 2 and -25 over 4. So the next part, my max or min and my range, these two pieces actually go together. So I'm going to box these two together and then draw a box through the middle. So the reason that my graph has a maximum is because it opens down. And the reason that it opens down is because a is less than 0. When I'm talking about a, I'm talking about the number that is in front of x squared when it's in standard form. So that is where this a comes from. And if it has a maximum and it opens down, that means that it has a range of y's that are less than or equal to some number, which we'll figure out what that number is in a second. And then if I have a minimum, the reason I have a minimum is because my graph opens up, and that opens up because a is greater than 0. So again, that number in front of x squared here is greater than 0. It's positive. And if it opens up, my range is going to be y's that are greater than or equal to. So looking at problem 1 in standard form, my number in front of x squared is 1, and that number is positive, which means my graph is going to open up. If it opens up, it has a minimum, and my range is going to be y's that are greater than or equal to, and the best part is I actually already know the number that goes here, and that number is -4, because whatever number is the y value of my vertex is also my minimum, and it has to do with my range. And then remember that whatever was the x value of my vertex was also my axis of symmetry. So those two numbers went together. So look at problem 2. Well, problem 2, it has the number in front of x squared is a 1, and it's positive. So again, my graph is going to open up, and if it opens up, it has a minimum, and my range is y's that are greater than or equal to. And again, I already know what number that is. It's going to be -1, and that -1 is because that was the y value of my vertex. Problem 3, I have in standard form y equals +1x squared plus 6x plus 8. So again, I know that this graph is going to open up. And the reason it opens up is because this 1 here is positive. So since it opens up, my graph has a minimum, and it also has a range of y's that are greater than or equal to, and the number that goes there with my minimum, the minimum value of my function is -1, and the range is y is greater than or equal to -1, because that was the y coordinate of my vertex. And lastly, problem 4. My equation was y equals x squared minus 5x. Again, that 1x squared is positive, so my graph is going to open up so that it has a minimum, and the range is y's that are greater than or equal to. And that minimum value and my range are both going to be -25/4, because -25/4 was the y value of my vertex. So notice that the only thing we haven't filled in yet on all of the problems is my domain. Well, I just want you to remember that your domain every time is -infinity is less than x, which is less than infinity. So I've gone ahead and written that in there for all of my domains, and that will be the case as long as your graph is not a word problem. When they're word problems, we get things a little bit differently.